Hey, Dr. Lane. So I'm going to do the reassessment for the midterm. I'm not going to read out each question because I know you already have them, so I'm just going to start explaining. So in the first one, we're given the location and the charge and everything. So we find our radius right there. Our velocity is also given. So our radius is going to be 5 e to negative 3, 6 e to negative 3, 0 meters. We're also, from that we can also find our magnitude of r, and then we find our hat from that, and there it is. Doesn't have in units, and that's the magnitude equation that we're going to use. So if we plug everything in, u naught over 4 pi we know is a constant. Our charge was given, well, I'm pretty sure it's understood what it is, 1.6 e to the negative 19 coulombs, and then times the velocity divided by radius squared times the magnitude, r hat. Yeah, just r hat, not magnitude. Excuse me. And if you cancel all the units out, you're going to be left with t. So that's the first one right there. The second question is, so the first part asks us to draw arrows. So the first one would have a longer arrow because it would have a larger magnitude of the electric field because it's closer to the, I guess you would say, the two dipoles. The answer would be negative because the magnitude of A is much larger than B. So if you do VB minus VA, that's going to give you a negative answer. Also by the formula, the change of V equals negative E times change of I. Here we're not going to integrate. Let's see, I wrote because it's a component. Oh yeah, because X is the only component that survives. So we could just plug in our B and A and into X, and if we do that, that's going to be the answer. And I think it's going to be correct because the units are going to give us units divided by coulombs. So this next portion right here, the disk. So what I did is I wrote down the equation E disk minus X in this case, Q divided by A over 2 E naught times 1 minus X over R, because X is less than R in this case. So if you rewrite that just for the X component, because that's the only direction we're moving in, we're going to get dq over, if you rearrange that, 2 pi r squared E naught times 1, times 1 minus A minus X over R. So where dq is, so if we kind of cut this up, and dq is just the charges, I guess you would say, acting just on this one piece of the electric field. We could add up, if we kept doing that, we could add up all the pieces together and get the answer. So we'd set up like a ratio, dq over q equals, so dq is going to be pi, it's going to be pi r squared dx, because this would change, whereas this doesn't. So if we rearrange that for dq, we'd get q over L dx. So we plug that in, and that's what we get, and we would integrate from 0 to L, and that would be our answer. And the three reasons we check this: first is the units. You see it right there. I think I got that right on the test. If you take the integral if you take the integral and as it goes to pi, the field should go to 0. Like if you plug in for A, but A is not in the actual, it's not a variable, it's not in this equation, so this can't be correct. And the direction is wrong. It's supposed to be in a positive X direction, as you can, positive A, I guess, so X direction, as you can see, and it doesn't, it goes in the negative. That's what the answer says, so that's wrong. And the very last one, this part, I just did my charges like this, which I think I also got that correct on the test. And this part, the what's it called, ED, where we had to do the electric field to just the dipole. If you add the vectors together, it's going to be pointing to the right direction. So the E pole, due to the charges by the way, the charges on the outside of the sphere would be negative right here because it is a it is metal. It's it's a conductor, so it's zero, it's net zero. So that's why if ED of the just on the dipole is going to the right, E pole would be going to the left to cancel that out to give us zero. So that's my reassessment. Thank you.